Okay, so this is a Unit 1 test review, Part 2. So, for the first problem, is the equation 5x plus 3 minus 2x equal to 7x plus 3 sometimes, never, or always true? So what we're going to do is we're going to start by solving this. We want to get it simplified. So I am going to start by combining like terms. So on the left side I have 5x and negative 2x. I can combine those. So when I combine the 5x and the minus 2x, I get 3x plus 3 is equal to 7x plus 3. And already we should be able to tell that this is not completely equal. So if we continued to solve this, we'd end up with 3 equals 4x plus 3. And then subtracting the 3 from both sides, I get 4x is equal to 0. And then finally, dividing by 4, I end up with x is equal to 0. Okay, so what this means is that there is one number that we can plug in to make this equation true, and that is 0. So for this one, it is sometimes true, because there are numbers that I can plug in that will make the equation untrue. There are numbers that I can plug in, or at least one number that I can plug in that'll make the equation true. Okay, so it's not always true. And an equation that's always true would look like if I had 3x plus 2 equals 3x plus 2, or something like that. Or if I solved it all the way down and I ended up with 0 equals 0, or like 7 equals 7, or something like that. Okay, so always true is when I don't have a variable left anymore. It ends up with a number being equal to a number. 0 is always equal to 0. 7 is always equal to 7. So if we get something like that, that's when we say it's always true. And then for it to never be true, that's when we simplify and we end up with something like 7 is equal to 6. Or like 0 is equal to 5. Okay, that's not true. Okay, so if we simplify and we end up with something that looks like this is where it's never true. This will be where it is always true. And then for our case, we ended up with x is equal to a number. So this number makes my equation true, but there are also numbers that make it untrue. So that means that it is sometimes true. Okay, for the next problem, determine if y varies directly with x. If so, what is k? So to vary directly, to be a direct variation equation, it has to fit y equals kx and nothing else. There shouldn't be a number added or subtracted. It should just be a y, an x, and then whatever k is, our constant of variation. So we're going to solve for y. We're going to isolate y and see if it fits this equation. So for the first one, I am solving for y, so I would get rid of anything that's on the same side as y. So in this case, it's the 2, so I divide by 2. And I end up with y is equal to 4 divided by 2 gives me 2. So I get y is equal to 2x. I'm going to flip that around so that my y is on the left side. So this does fit my equation. I don't have anything added or subtracted. I just have my y and my x. My constant of variation is the number that's in front of x. So the constant of variation in this case is 2. For the second problem, I have 9y equals 3x minus 6. So I'm going to start by dividing by 9, and I divide every single term by that number. So I get y equals, simplifying my fraction, 3 over 9, that simplifies to 1/3. And then 6 over 9 simplifies to 2/3. Okay, so this is not in the form of a direct variation equation. This is actually in y equals mx plus b form. Okay, so this is not direct. This would not go through 0, 0. To be a direct variation equation, the y-intercept is always 0. So in this case, we have a different number for our y-intercept. There's a number being added or subtracted. That means that that is not a direct variation equation. And then the last one, 9y equals 3x. So again, I'm isolating y. So I divide by 9 on both sides. and I end up with y is equal to, simplifying that fraction, I get 1/3 x. Okay, so this one does fit my equation. I have a y, x, and a number in front of x, that's my k. So this is a direct variation equation, my k is 1/3. And I forgot to write my k for the first one, the k for this one was 2. So k is whatever is in front of x. If there's a number added or subtracted to x, then that means that it's not going to be a direct variation. Okay. For the next problem, we're finding the equation of the line in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where m is our slope and b is the y-intercept. So in order to write an equation in this form, we need our slope and our y-intercept. So we are going to start by finding the slope. The slope is our rise over our run. So we need to find 2 points on our line, and it doesn't matter what 2 points we choose. So I'm going to find multiple points just to give you guys examples. So looks like this is a point that's on my line. This is a good point. This one. There are lots of points where it goes through the little crosshairs, and that's what we want. We don't want a point like, just, for example, like here. This point is, it would have to be something that we estimated. It looks like it's at maybe 2.6 and then down negative 0.75. We don't want to have to guess, okay? We want something that's right on the line. Something that's right on the crosshairs that you can tell exactly where it is, okay? So that's why I'm picking the points that I'm choosing. So it looks like maybe this one. Yeah, this line isn't very straight. So those are a few points that we could choose, and we really only need 2. So I'm going to use these 2 points. Okay, so for my first point, starting from my first point and going toward the right, it looks like I have to go down 2 spaces. So my rise is actually negative. If we have to go down, the rise is going to be negative, and if we go up, the rise is positive. So since we went down 2 spaces, my rise is -2. My run is 1, 2, 3. So my rise over run is -2/3. That's my slope. And then to find the y-intercept, this part's really easy. The y-intercept is wherever the line crosses the y-axis. So remember, the y-axis is this vertical line here. So I'm just looking at my line, and it looks like it crosses the y-axis right here at -1. So my y-intercept, b, is -1. And then I just take those points or take those numbers and plug them in. So y equals my slope, -2/3, x, and then plus b. In this case, b is negative, so I'm going to write -1. All right, my next couple questions, I'm writing the equations in standard form. So if I want to write these in standard form, first we should know what standard form is. ax plus by equals c, where c is a constant. X and y need to be on the left side, and we cannot have decimals or fractions. So we can see in this problem we have a fraction, so we need to get rid of that fraction. If there's a fraction in the problem and there's only one fraction, easiest way to get rid of it is just multiply by the denominator. We're going to multiply everything by the denominator. So for this one, I have y equals 2/5 x plus 3. The denominator here is 5, so I'm going to multiply the entire equation by 5. So I will do 5 times y. I'm going to write my new equation in blue. I get 5y. 5 times 2/5 x. When I multiply 5 times 2/5, I get 2. And then 5 times 3. Okay, now that I've eliminated my fractions, I'm going to go ahead and rewrite my equation so that my x's and my y's are both on the left side. Okay, and the constant should stay on the right. So here my constant is 15. I need to move the 2x to the opposite side. So to do that, it's a positive 2x. I'm going to subtract 2x. So I'm just going to write this over here. So I end up with 5y minus 2x is equal to 15. I'm almost done. The last thing I need to do is just make sure my x comes first and the y value comes second. So I'm just going to switch those two terms. The 2x, it's actually a negative 2x because of the minus sign. I'm going to write that in front. And then my 5y is positive, so I'm going to put plus 5y, whoops, equals 15. And now it is in standard form. The x and the y are on the left side, and I do not have any fractions or decimals. For the second one, I have y equals negative 1.5x plus 0.2. In order to change the decimals into whole numbers, so something without a decimal, we need to move our decimal points one space to the right. Okay, right now these numbers are in the tenths place. What we're going to do to move a decimal point one place to the right is multiply it by 10. So I'm going to take this entire thing and multiply it by 10. So 10 times y gives me 10y. 10 times negative 1.5x is negative 15x. We just took that decimal point, moved it one place over. And 10 times 0.2 is 2. And then next we just need to take our x and move it to the opposite side. So this time it's a negative 15x, so I'm going to add 15x to both sides. So I end up with 15x plus 10y equals 2. Making sure you write the x term first, the y comes second, and then our constant on the right side. And that is our equation in standard form. Okay, the next couple problems we're going to look at is writing inequalities given word problems. So the first one, we have a class picnic. A yearbook company promises to give the junior class a picnic if they spend at least $28,000 on yearbooks. Okay, so that number is going to be important. And this is also going to be important. So we want to spend at least $28,000 on yearbooks and class rings. Each yearbook costs $35. So our yearbooks are $35 each. And each class ring costs $140. So class rings are $140. How many yearbooks and class rings must the junior class buy to get their picnic? So we have to make at least $28,000 off of the yearbooks and class rings. So to figure out the total amount that they spent, we need to know how much they spent on yearbooks, and how much they spent on class rings. So the amount that they spent on yearbooks, we'll find that by taking the cost of the yearbooks. Okay, the cost of the yearbooks and multiplying it by how many yearbooks were bought. And we do not know how many yearbooks were sold, so we are just going to call it y. So it's $35 each, that's 35 times y. And then we're going to do the same thing with class rings. We don't know how many class rings were actually bought. We'll call that r. But they are $140 each, so we're going to say 140 times r. Okay. So the total amount spent then is going to be given to us by adding our amount we spent on yearbooks plus the amount that we spent on rings. And we want that total to be at least $28,000. So we need to figure out what inequality goes here. So the inequality that matches up with at least is greater than or equal to 28,000. The amount that they spent can be equal to 28,000, that'll reach the goal, or it can be greater than 28,000. Okay, that's what at least means. And that is our inequality. And we are not going to solve it. We're just trying to actually write the inequality. We're just getting practice at writing them. So for the second problem, Mr. Schoolcraft goes to the grocery store to buy cereal and milk for his breakfast. Each box of cereal cost $4, and each gallon of milk costs $3. He is on a budget and can only spend $25 on food. Write an equation representing the situation. So we want to spend no more than $25, and we're actually going to write an inequality, not an equation. Inequality. Okay, so $4 a box for cereal, so $4 per box. We're going to represent that with 4x. That'll give us the total cost of how much he spent on cereal. So for example, if we plug 1 in here, for 1 box of cereal, he spent 4 times 1 gives me $4. If he bought 2 boxes of cereal, 4 times 2 would be $8, and so on. And then looking at the gallon of milk costs $3 each. So to represent the total cost for milk, we're going to say 3y. Okay, so we have the amount that he spent on cereal and the amount that he spent on milk, the total of which needs to be no more than $25. Okay, so this amount could be equal to 25, so our inequality will have an equal sign under it, but it cannot be more than that. So it needs to be less than or equal to $25 in order for him to stay on his budget. And that is our inequality. Okay, for our next problem, a cell phone plan charges a startup fee of $50 and then $45 per month. We want to write the expression that models the cost of the plan. So we're writing an expression here, which means it's not going to have an equal sign. So it looks like we get charged $50 for our startup fee. That is going to be the base fee. It does not change. We're going to have to pay that no matter what. And then on top of that, we get charged $45 per month. So there's that word per again. So for every single month, for each month, anytime we hear any of those words, we're going to take our amount, whatever it is, and multiply it by that number or variable in this case. So we're going to call a month M. So it's $45 per month. We don't know how many months we're going to keep this plan. So we'll represent this using 45M. Okay, and then the last thing we need to do is just add in our plus sign here because we are going to spend $50 in addition to however many months we stay on, $45 per month. And that's our expression. Okay, our next problem, write the inequality for the given sentence. 8 less than a number is no more than 12. So, less than, if there is no is in front of that, the word is, if we have is less than, that's when we have the inequality, okay? Without the is, though, less than means the same thing as subtraction, okay? So 8 less than a number. This is where our variable is going to be because we don't know what that number is. And remember, less than, fewer than, things like that, those kinds of phrases, we're actually going to take whatever comes second, subtracting the number variable that comes first. Okay? So this should be n minus 8. Is no more than. So we need to think about what is no more than means. That's going to be our inequality. If something is no more than 12, that means that it could possibly be equal to 12. It just can't be more than that, which means it needs to be a less than symbol. So is no more than 12, and that is our inequality. 8 less than a number is no more than 12. If you are having trouble with the inequalities, like such as no more than, I did post a handout on Google Classroom that will help you with translating those inequalities. So if you want to, then take a look at the handout. It's from a few weeks ago, so it's probably going to be further down on the list. But those inequalities and the phrases for the inequalities are all on there. You could also try Googling it, and that'll also show up. Okay, next problem. Is the inequality always, sometimes, or never true? So we're going to start by solving this. So I distribute negative 2 times each term inside my parentheses. So I'll get negative 6x minus 2 is greater than negative 6x plus 7. Okay, I'm going to add 6x to both sides. And what I end up with is negative 2 is greater than 7. So I just need to think about whether or not this inequality is true. Negative 2 is greater than 7. This is untrue. In fact, it is never true. Negative 2 is never going to be greater than 7. So this inequality is never true. Okay, find the slope of the line that passes through the given points. So remember the equation for slope, y2 minus y1 over x2 minus x1. We're going to use this formula, plugging in our numbers. I'm going to label this x1 and y1, x2 and y2. So when I plug those in, I get 11 minus negative 4 on top, and 3 minus 10 on the bottom. So looking at the numerator here, 11 minus negative 4. If we have minus and negative, we're going to change that to a plus sign. Minus and negative means we just add the numbers. So 11 plus 4 is going to give us 15. And then on the bottom, 3 minus 10 is going to give us negative 7. And there's no way to simplify this. Normally, if we had a fraction, we'd try to simplify it. And in this case, there are no numbers we can divide out of both the numerator and denominator. So our final answer is just the negative 15 over 7. For the second problem, same thing. I'm going to label this x1 and y1, x2 and y2, and then I'm going to plug them in. So 4 minus 3 over 5 minus 0. I get 1 over 5. And there's no way that I can simplify this, so I leave it as 1 over 5. Alright, for the next one, we're finding a point-slope equation for the line containing the given point and having the given slope. So for number 1, I've got 4 and negative 3 as my point. My slope is negative 1. The point-slope form is written as y minus y1 equals m times x minus x1. So when I plug in my numbers here, my 4 is my x1 and negative 3 is my y1. So I'll have y minus negative 3 equals negative 1 times x minus 4. So I can simplify two things here. I'm going to be able to simplify the minus negative, and then I also am going to drop out this 1. Remember, negative 1, if we drop the 1 out, the negative symbol in front of the absolute value, it implies, the 1 is implied. Okay, so if we drop that off, we'll have y plus 3 equals negative x minus 4. If you really wanted to leave the 1 there, it wouldn't necessarily be wrong. It's just not completely simplified because we don't write anything that we don't have to write. And that 1 is implied here when we have this negative sign. Okay. For number 2, doing the same thing, just plugging in. So y minus negative 6 equals 2 times x minus negative 5. So again, I'm changing or simplifying the minus negatives. Going to simplify that to plus signs. So y plus 6 is equal to 2 times x plus 5. Oh, way off. There we go. Okay, for number 3, doing the same thing. This is x1 and y1, and we're just plugging them in. So y minus my y1, y minus 2, equals my slope times x minus my x1. So again, we have minus a negative, so we are going to change that to plus. So this is going to be y minus 2 equals 3 times x plus 7. And then finally, I have my number 4 here, x1 and y1, labeling those, and then plugging them in. Y minus my y1, y minus 5, equals my slope times x minus x1. And that's it. Okay, for our next example, we're finding an equation of the line that passes through 4, 6 and is parallel to the line whose equation is y equals 2/3 x plus 5. So parallel lines, if you guys remember, parallel lines have equal slopes. So if the slope of this equation is 2/3, my new equation will also have a slope of 2/3. And I know that because they're parallel lines, equal slopes. So I have m is 2/3 and my point 4, 6. So I'm going to write this equation starting off in point slope form, and then I'm going to simplify it to slope intercept form. So I plug in y minus 6 equals my slope times x minus 4. And then to change this to slope intercept form, I'm going to distribute the 2/3. So I distribute my slope. 2/3 times x is 2/3 x. 2/3 times negative 4. When we multiply a fraction by a whole number, all we do is we take the numerator times the whole number and we keep the denominator. And then we'll simplify. So negative 8/3. And I'm going to leave that as a fraction because if we change it to a decimal, it's going to have a repeating decimal. So it's just easier for us to leave it as a fraction. So minus 8/3. And then the last thing we're going to do is add 6 to both sides. So I get y is equal to 2/3 x. And then here, when I take negative 8/3 plus 6, what I'm going to do is I'm going to change 6 into something with a 3 as a denominator. So if I want to make the 6 have a 3 as a denominator, all I do is multiply by 3/3. This is the same thing as multiplying by 1. 3 divided by 3 is just 1, so I'm not changing anything about this number. So 6 times 3/3 is 18/3. So then when I take 18/3 and I add it to the negative 8/3, that's going to change into a positive 10/3. Okay, so negative 8/3 plus 6 is 10/3. And then my final answer then is this equation, y equals 2/3 x plus 10/3. Okay, so the next thing is finding an equation of a line that passes through 5, negative 2, and is perpendicular to 4x plus 3y equals 12. So if a line is perpendicular to this equation, its slope is going to be the negative reciprocal of this equation's slope. In order to figure out what the equation's slope is, I have to put it in slope-intercept form. So to do that, I start by subtracting 4x from both sides. So I get 3y equals negative 4x, going to be up front, and then plus 12, and I divide by 3. So I end up with y is equal to negative 4/3 x plus 4. So the line that is perpendicular to this line, its slope is going to be the negative reciprocal of negative 4/3. So the negative reciprocal means that we take the number, we flip the fraction, so we're going to switch the numerator and the denominator, and we also change the sign. So since this is negative, the negative reciprocal of this will be positive, and it's going to be a positive 3/4. So this is the slope of my new line. So I know what the slope is for my new line. It's going to be 3/4. And I also know that it passes through this point. So I'm going to start by plugging it into point slope form and simplifying it to y-intercept form. So y minus negative 2 equals my slope times x minus 5. And I got the negative 2 from the point, that's my y value, my y1. And I got this 5 from the x value. So now I'm going to simplify. So first I'm going to change this, since it's minus and negative, I'm going to change that to plus. 3/4 times x gives me 3/4 x. 3/4 times negative 5 gives me minus 15/4. And then the last thing I need to do is subtract 2 from both sides. So I get y equals 3/4 x minus 23/4. And that's my equation. And I apologize for these examples being so weird with the fractions. Okay, so we're finding the inequality for the graph. So first thing I'm going to look at is writing the line, the equation of the line. So we need our slope and we need our y-intercept. It's going to be in this form, except we're going to have an inequality instead of an equal sign here. So my slope is found by finding my rise over my run. So choose 2 points that are on your line. I'm going to choose this one and this one. And there are multiple points you can choose. Looks like there's some here, there's another one here. You can choose any of these points. You need 2 points. Starting from the left point, working toward the right point. We need to figure out our rise over our run. So I'm going up 1, 2, 3 spaces and over 1 space. So it looks like my rise over run is 3 over 1. So my slope is equal to 3. Next, I need to figure out what the y-intercept is. The y-intercept is wherever our line crosses the y-axis, and it looks like it crosses it right here. So my y-intercept is at -1. And now I just need to plug these numbers in. So I have y. I need to figure out my inequality. So it's a dashed line. That means that it's not going to have the equal sign. Remember, if we have less than or greater than, those lines are dashed. Less than or equal to, greater than or equal to, that's when we have the solid line. So in this case, we will have one of these. To figure out which one, we look at the shading. The shading is below the line. So since it's below the line, that means that our inequality is going to be a less than symbol. So y is less than the number we found for our slope times x, and then putting in our y-intercept, -1. And that is our inequality. Okay, so the next one we're looking at is an absolute value function. I know that because it's in the shape of a V, and it is symmetrical about the axis of symmetry. First thing I need to do is figure out what my vertex is. So the vertex is at +2, +3. Next, I need to know what my slope is, or the stretch or compression. And I find that by finding my rise over my run. So starting from the vertex, we're going toward the right, up 1, and it looks like I'm going over 1. Up 1 and over 1, up 1 and over 1. So the slope, or the compression or stretch, whichever you want to call it, is 1, which means that we actually didn't have a stretch or compression. It's the same as our parent function. So we're going to plug those numbers in. So remember the function for absolute value, y equals a times the absolute value of x minus h plus k. I also need to figure out what inequality symbol I'm going to use. That's what we're going to put in for the equal sign here. So it's a dashed line. That means that it's either going to be a greater than or a less than symbol. And then it's also everything below that dashed line. So if it's below the line, it's a less than. Okay? If it's dashed, we don't have the equal sign under here. So that's how we knew it was either a greater than or less than. And then since it's shaded below, we know that it's less than. So that's what we're going to plug in. So y is less than my slope, my stretch or compression, 1, absolute value, x minus 2 plus 3. Just plugging in all of the numbers that we found. Now, since this 1 is here, we actually don't need the 1. Remember I told you guys in class, if we have 1 as our slope from the vertex to the right, that means that we don't actually write it. It's just absolute value of x minus 2 plus 3. Because what that 1 indicates is that we didn't have a stretch or a compression of any kind. It didn't change. That didn't change from our parent function. So the only things that we did change from our parent function is that we moved to the right 2 spaces and we moved up 3 spaces. So this is our inequality. Okay, next we're looking at direct variation. Is this a direct variation? If yes, give the constant of variation k and the equation. So direct variation is y equals k times x. To figure out if this is direct variation, we're going to take our y's divided by our x's. So we're going to do 6 divided by 4, 12 divided by 8, 18 divided by 12, 27 divided by 18. If these don't divide evenly, what we're going to do is just reduce the fraction. So for the first one, 6 over 4, that reduces to 3 over 2. When I do 12 over 8, that also reduces to 3 over 2. So far looking like a direct variation. Let's keep going. 18 over 12 reduces to 3 over 2. And then finally 27 over 18 also reduces to 3 over 2. Okay, so this is a direct variation. Whoops. And our k is 3 over 2. So when we're writing the equation for this, if we know our k is 3 over 2, all we have to do is take k, plug it in. So the equation is going to be y equals 3 over 2x. Okay, so the amount of heat, H, produced in the human body by burning of proteins is directly proportional to the amount of proteins A burnt. If burning of 1 gram of proteins produces 32 calories of heat, how many proteins should be burnt to produce 52 calories? So H is directly proportional to A. That means that we can set up a proportion. I'm going to do A over H equals A over H. Okay, so A represents the amount of proteins. So in our problem here, burning 1 gram of proteins, that's A, produces 32 calories of heat. So that's H. How many proteins, so how many A, should be burnt to produce 52 calories? So the first half of the proportion is going to be A over H, so 1 over 32 equals. For the second one, we're looking for A, and H is 52. After we set those two up, we cross multiply and divide. Okay, so we end up with A is equal to 13 over 8, or 1.625. Okay, so 2 buses leave the station at noon in opposite directions. One bus is traveling at a certain speed, and the other travels 15 miles faster than the first. After 4 hours, the buses are 640 miles apart. How fast is each bus traveling? So our variable in this case is going to be speed, because that's what we're looking for. How fast were they going? So here when it says one bus is traveling a certain speed, we don't know what that speed is. That's what we're going to call x. The other travels 15 miles faster than the first. So if I'm going 15 miles more than the first bus, I'm going to call that x plus 15. After 4 hours, the buses are 640 miles apart. So we're going to pretend it's been 4 hours. The distance is now 640 miles between them. So what we need to do is we need to find a way to represent the mileage for each bus. We're going to take how far the first bus traveled, the distance of the first bus, plus the distance of the second bus. And that's going to give us a total of 640. So my first bus, to figure out distance is equal to the time multiplied by the speed. So it even tells us the time. They've traveled 4 hours. So I'm going to do 4 hours. The speed is x. So this is the distance of the first bus. The distance of the second bus is going to be the time, 4 hours, multiplied by the speed. So the speed of the second one is actually x plus 15. And then I'm going to simplify that. Okay, so 4 times x is 4x. 4 times 15, there we go, is 60. I'm going to bring this down. Okay, so this is the speed of my first, or distance of my first bus. This is the distance of my second bus. And when I add those distances together, they've been traveling in opposite directions. Their total distance between them is 640. So all I need to do is solve this equation. And I'm going to continue this onto the next page. So, distance of the first bus plus the distance of the second bus equals 640. So 4x plus 4x gives us 8x. And then I'm going to subtract 60 from both sides. So I get 8x is equal to 580. And then I'm going to divide by 8. So I end up with x equals 72.5. Okay, so that is how fast the first bus was going. The second bus was traveling 15 miles more than that, so x plus 15. So when I plug in x, 72.5 plus 15 is going to give us 87.5. Okay, so first bus was going 72.5 miles per hour. The second one was going 87.5 miles per hour. And that is not good. Never do that. Never go this fast. Alright. Anyway, so that is the end of our problem. Okay, finally, actually not finally, one more slide after this, just the end. They're solving the indicated variable, or solving for the indicated variable in the parentheses. So that means that we've got literal equations. P is equal to IRT, we want to solve for T. So what we're really doing is just isolating T. So we have I and R to get rid of. This is I times R times T. So in order to get rid of I and R, we're going to do the opposite of multiplying. We're going to divide by them. And if we do that on the left, we have to do it on the, if we do that on the right, we have to do it on the left. So I end up with T is equal to P over IR. And of course, we always want our variable to be on the left side here, so just switching those around. For the second one, we've got A equals 2 times L plus W, and we're solving it for W. So here, to get rid of the 2, I'm just going to divide. So I get A over 2 equals L plus W. And then I just need to subtract the W. Or, the L. So I end up with A over 2 minus L equals W. And then, of course, I'm just going to flip that around. W equals A over 2 minus L. Okay, for the next one, I'm solving 2x minus 3y equals 8, solving it for y. So I start by subtracting 2x from both sides. So I get negative 3y equals 8 minus 2x. And then I just need to divide by the negative 3. Now this problem is not necessarily asking us to put it in slope-intercept form, it's just asking us to solve for y. So I get negative 8 over 3 plus 2/3 x. And then if we wanted it in slope-intercept form, the x coming first, we would just move this term to the front. And I don't have any more room, so I'm not going to do that right now. And then the last one, v equals LWH, and we're solving it for L. So again, this is all multiplication, L times W times H. So to get rid of the W and the H, we undo the multiplication by dividing. So we're dividing by both W and H. So we end up with L is equal to V over WH. And of course we write the variable on the left side, so we're just going to flip those around. And that's all. Those are our literal equations. Literal equations. Okay, and that is the end of the review. So hopefully you guys are ready for the test tomorrow, and I will see you bright and early on Friday morning.